Hey, good afternoon, everyone. I just got word from Bruce and he'll be joining us shortly. Oh, and there he is. So I'm just going to do a quick introduction. First off, thank you everyone for joining us for the webinar about solar batteries and energy storage. We have South Carolina board members Bruce Wood and Jamie Brown here as our presenters. Before I hand the conversation over to Bruce and Jamie, I would like to invite you all to mark your calendars for our spring awards meeting. That's going to be held via Zoom on May 18th at 1 o'clock. And we look forward to celebrating our local solar champions and hearing a utility update. Without further ado, Bruce and Jamie, the floor is yours.
Good afternoon. This is Bruce Wood with Sunstore. I hope everyone's having a good day today. And we want to take a little time and talk about some of this storage technology. And I appreciate everybody being here. There's a lot of change that's going on, taking place as we go through the different technologies and different manufacturers. And so it's pretty important that we, I think, keep the accurate information going as far as what's available and what it will do, and set the proper expectations. So with that said, Jamie, you go ahead. Is Jamie with us?
Yeah, I'm here. I was trying to get it unmuted. Had my phone put down. I'm here to answer any questions anybody's got, or at least try to answer the best I can. I've been doing batteries for a while, but the battery technology is changing out there so much that it's kind of hard to keep up here with it lately. Just with the new LG Chem batteries that just came out. I'm actually having to relearn some of that stuff now. And once that technology came out, it's made it easier to install than when I first started. But still, there's so much computer stuff and electronic stuff nowadays that it's made it easier to install, but it's harder to work on, is what I'd say on that. Back when I started, it was string inverters hooked into charge controllers, hooked into lead acid or some batteries like that, and you just simple setup process. Nowadays, it's Solar Edge or some other type of microinverter or whatever, hooked into a lithium-ion battery pack, and pretty much stand there in front of the system and programming a computer is what you're doing. So technology has come a long way, and it's a lot more efficient. As you know, like I said on the one that I did about my personal system, if you take a 3,000 to 4,000 square foot house and put it off grid these days, you can do almost anything with batteries. But to do that, you have to have a lot of you got to take a lot of care with how you size your system and with what you have in your system as far as the appliances and everything in your house. Everything has to work together just like two gears meshing together, spinning. If one of those gears isn't meshed right, everything's going to fall apart. But yeah, I can try to answer any questions after Bruce gets done with his stuff. Bruce, back to you.
All right, thank you, Jamie. Yeah, like Jamie said, the battery technology has been changing quite rapidly, but we're going to kind of start and keep it simple to begin with here. When you're looking at incorporating a battery with an inverter and a solar system, there's generally two types of approach to it. One is DC coupled and the other is AC coupled. Originally, most everything was direct DC coupled, so you generate direct current. With your solar, you go through the charge controller, as Jamie mentioned, and you would store that in the battery. Your inverter would pull the power back out of the battery, and then it would turn it to the household current, 120, 240 volt AC, to use to run the loads. So that's the way solar originally started. And then a few years into it, we were able to get some technology that would allow a battery and an inverter to connect with another inverter on the AC output side. And so that kind of changed the way we had to do things. And we were able to put in almost like UPS systems that you might have in an office building that takes the batteries and turns it into the AC current, and then it would interact with the solar inverter. So you didn't have to have those directly coupled. Most people, well, we still have both types available. If you use I guess the old-fashioned technology, which you can still do, and just do, say, a Snyder or a Solar inverter or an Outback Radian, you're going to be doing the DC. So you're going to be charging the battery from your solar direct current, and you're going to have the inverter there to provide downstream to supply the loads. A lot of the other batteries now, we're beginning to see, like LG Chem that hooks up with the Solar, they store the DC voltage at around 360, 380 volts. And so those are the kind of the old fashioned, it's a modified DC connection there. So you're stepping up your battery voltage, reducing the current that's output. And so it really is going to depend on which manufacturer. The Tesla has a battery and inverter in one package. And so that would interact with your solar inverter that's either on the roof or your backup power inverter. So that would be an AC coupled example there using the Tesla. So, like I said, you have different approaches to doing it. The old fashioned way was the straight DC. A lot of the new technologies are going to high voltage DC coupling, but then we have a lot of more standalone solutions like the Tesla and some of the others that are AC coupled. The in-phase in-charge battery system, the battery has an inverter on each one, so that the inverter itself is going to couple on the AC side with your solar system. Now, as we begin to talk about the different manufacturers, like I say, you have Enphase, Tesla, several others that are working on the AC couple side. And then you have a lot more that are probably working on the DC couple side. Like I say, I think the Solar Edge, the SMA, when you do the storage unit with SMA, that's a DC coupled, high voltage DC coupled battery. And so those, they both work very well, but you just have to approach them in a different manner and as how you're designing it and how you're going to operate it. Are there any questions at this point about, the types of storage systems there? And we can get into discuss the battery chemistries, but I think right now, for the most part today, we're going to be talking about moving from the lead acid to moving into the lithium phosphate and lithium ion batteries. I think I saw a question pop up on the screen there. Can you see that, Roxanne?
I can. It is from Tim Hanna, and it says, is it practical to have battery storage with no solar at this time?
Would you repeat that? I'm sorry.
Yes. Is it practical to have battery storage with no solar at this time?
I think what's your expectations for having the battery? Why are you going to put the batteries in is the biggest question that I usually try to ask people. Are you looking to put backup power in so that you have secure power when the utility is down? Or are you looking to shift your rate schedule so that if you're on, for example, a time of use rate, so that you can use your battery when the price is high on electricity, and you can charge your battery when the price is low on electricity. So you have two different reasons to put batteries in. One is to rate shift, which makes a lot of sense if you're in California or some of these others, or if you go to a utility that's going to only give you avoided cost for whatever you send back. you can use the battery technology to store your solar electricity and then use more of it at your home or business. So you're not sending it back at the discounted rate. The other, which is probably what's been the most popular throughout the years, was to use the solar as a backup power source in the event of a weather issue or ice storm or windstorm or whatever knocks the utility out to your house, and you can keep your home, your refrigerator, your well pump, your basic needs covered. As a general rule, we don't normally go in and cover full home systems that will run everything in your home. We can do it from a technology standpoint, but from a cost standpoint, it gets a bit prohibitive. Did I answer that question?
Did that answer the question? He did mention yes. Okay, good. He said yes. I guess this is a question. Good.
As far as whether it makes sense or not, it really comes back down to an economics. From a technology standpoint, we can do it. My feelings are that within 3 to 5 years, the cost of batteries is going to come down. The energy management systems, the smart main panels in your home that can control the loads, those things are going to come together along with less expensive solar. And we'll begin to see a lot more people move to try to do whole house because you can manage loads if you have the right systems in place. And also, as the cost comes down on the batteries, we'll begin to see it much more cost effective and people utilize them. For now, most of what I see is backup power. Like I say, we have a few utilities that we've put systems on for self-consumption because the utility was not going to give you much money for what you sent back. And if you stored it yourself, you could offset the full retail rate. So most of our utilities, as long as you're on full retail net metering, there's no economic advantage or incentive to do a battery to shift the rate, only for backup power.
Yeah, I can add something into here on that. Some of the systems nowadays, for the time of use and everything like that, you're able to program them of when to discharge the battery and when to charge the battery. Like Sonnen and Solar Edge, some of those you can do that. Back in the day, it was either all on or all off. You couldn't do any of that stuff. And some of the string inverters, I can't remember. Bruce might know this better, but I think the SolarArcs now, I think, had the technology for discharge. When they first came out, they didn't, but I think they do now. But that's what I'm seeing a lot of nowadays. I got three battery systems on now on co-ops that we discharge it, during peak hours now, and they just charge whenever I got them set up to charge when the sun comes up, and they just discharge whenever they need to offset the peak demand whenever the customer gets home and things like that, whenever they need the power and not pull from the grid. Back to you, Bruce.
So, deciding to install a battery system, I talked to a lot of people and almost everybody is asking about batteries. But when you get down and explore the real needs, I'm going to say it probably reduces our battery market down to around 20 or 25% of the people that inquire about it. Some people definitely have a need to have backup power at their home for whatever reason. And some people do have the need to shift, as Jamie said, if you're on a certain utility, and that makes sense. One of the other things that we have a lot of people that have inquired about throughout the years, and I started doing solar batteries in 1997 for the Y2K boom. A lot of people said the grid's going to crash. We're going to be 2 years without power. And so we helped a lot of folks to put in direct solar DC systems that stored the power and then would generate power to run the home. And since that time, we've had a lot of different things. One of them was the end of the Mayan calendar. We've had the CIA come out and talk about the threats to the power grid. We have a lot of people out there, and we refer to them kindly as preppers. There's a lot of folks out there that want to be prepared in the event of whatever. Some are looking, what if we have a nuclear explosion and it wipes out the grids? I want a system that I can operate then. You get into EPD hardening on those. So you're going to EMP hardening so that you can deaden the electromagnetic pulses and not let it come back in and destroy your system. So a lot of people that do it for a lot of different reasons. And when it comes down to somebody who's wanting to be a prepper, so to speak, and be able to have this thing to operate in the event of a really bad situation for whatever that could be, then we always want to talk to people about their internet connected batteries. If you're going to do an internet based system that works, for example, the Enphase or the Tesla, without the internet and being able to go in and, as Jamie had mentioned, programming all this thing through the internet and having the internet available, a lot of these things would just simply be a brick. If the internet was down and the power lines was down, you may or may not be able to operate some of these systems. So we have other systems that are designed not to go through the internet, not to have those interdependencies. And some particular one would be the Solark. You can order a Solark, which is not dependent on the internet. It can send its information up so you can monitor it, but it is not dependent on the internet to operate. And also you can order those with the EMP hardened, where they put ferrite rings around the different conductors coming in to take the EMPs and kill them. And also they have ferrite rings for your solar system and for your battery cables and stuff like that. So depending on what purpose someone's doing, and I got a lot of technology buffs out there that, they've got a couple of Tesla cars and they love the Tesla battery and they don't mind that it's interconnected through the internet because their car is too. So they're comfortable with that. But I've got other people who, if everything breaks loose and they have no internet, they have no utilities, they want to make sure that they can operate their system and not be interdependent on that. So, that's important when you start to look at these to decide what you really want to do, your end goal with it, so you can choose the right equipment. As Jamie said, some of these things are getting really complicated. If you don't have pre-approval from the Enphase ensemble design team, when you go and install an Enphase battery-based system, the InCharge and Empower system, without their approval prior for the design, you cannot turn that on. It'll sit there and it won't do anything until you've been able to connect it back through the internet and they validate it and then put it into operation. So, like I say, those are some things that gets a little more complicated. I did read where somebody in Puerto Rico stole a bunch of the Tesla power walls and found out that they were nothing but very heavy electronic bricks, because without going back and getting the validation through Tesla, the machine will not cut on and work. So, like I say, there's a lot of interconnectivity there, interdependability, and it's not bad as long as you know what you're getting and know how to deal with it. Jamie, you want to add something on that part of it?
Yeah, Bruce, you're right. They're nothing but a bunch of bricks unless you had the internet on them. I got a customer who has a Sonnen, and we installed, well, actually two of them. One of them that has internet to it, the other one did not have internet, and the customer did not have full-time internet. And what happened was they did a firmware update. Well, it just so happened they were in the middle of the firmware update, and the internet turned off right there in the middle of it. So they had a brick sitting there until I could take an SD card and put in there and reprogram their system, reprogram the firmware into their system, and then they were back up and running. The other one didn't have any internet at all, and so the system was there trying to find the mothership, so to speak, and it was just sitting there lost and didn't know what to do because it didn't have, the actual brains of the system, which is on a server out in California, to tell it what to do. So whenever you got an internet dependent system, you're gonna have to have full-time internet to it, and which is good for efficiency purposes and firmware updates and getting the latest, greatest, programming there. The only problem with that is if there's a EMP or nuclear thing or sunspot or something like that that wipes out the internet, it's no good. But which is the old technology, the stuff that Bruce and I, kind of started doing a long time ago, that you're not dependent on the internet. You're not dependent on, is the internet going to go down one day or anything like that. It's pretty much you set it and forget it. My system, I have not touched the programming in my system in over 2 years. I haven't even, the only thing I do is I look at the monitoring page to make sure everything is good. But as far as any of the programming with it, I haven't even fooled with it. And I got several systems like that right now that, once I install it, tell the customer where to look just to make sure that there's no warnings or anything on the page. And they ask, well, am I going to have to do anything with it? I was like, if you do something with it, you're going to be writing me a check whenever I come out here to fix it, because it's set up. You don't have to worry about it. So those are the good systems. I've seen the electronic systems where they work flawlessly, and like I said, they're good for efficiency, because if there's anything that needs updating, it automatically does it. Yeah, it's just whichever one you get. But I know Bruce does this, and I do it too. We don't sit with one particular type of system to where we sell only Sonans, only LG Chem, only Solarc, you have to sell the system, and you have to install the system that matches what the customer's needs are. Are there one size fits all type of systems out there? Yeah, but one customer is going to need one particular amount of power, and another customer might need half of that amount of power. And if you got a customer that needs, say, 17 kilowatt hours of power, then you get them 17. But then if another customer only needs 14 kilowatt hours, you don't need to give them 17 kilowatt hours of power, because you're giving them, you're wasting the customer's money with that. But yeah, does anybody have any questions or anything?
I actually have two things. One, is there a price difference between the battery or the ones that are internet reliant versus not?
There's a big price differential between systems, period. The same capacity from different manufacturers, you see some pretty wide variations in the prices. As a rule, the internet dependent system is not usually that much more expensive. There's not a whole lot of cost differential between the two. It's just really how they operate and what you want to do with it. So as Jamie said, it's most important that we understand what the customer really wants to do with it, how he wants it to respond at what times, so that we can just guide them in the right way. So I wouldn't say there's a price differential. The bigger price differential comes into how many kilowatt hours you want to have in your storage. Now, one thing I learned a long time ago is if somebody wants me to put a cheap system in and I don't put enough batteries in, it'll last for a little while, but those batteries are not going to last long if you run them to death. And so putting enough batteries in, if a guy's expecting a couple of days of backup power and the backup power goes out after about 4 or 5 hours, he's not going to be very happy. And so you've got to size it appropriately for the load. And that really changes the price there more than the type of inverter that you'd be looking at.
The big price difference that I see on, the internet-based systems or non-internet-based systems is in the labor cost. The ones that are, you just open up a box and throw a lithium-ion battery on the wall and plug in a couple of cables, those you can do a whole system in a day like that, where some of the string inverter systems and ones that have charge controllers and different things there, you can spend 2, 3, I've actually spent up to 5 days wiring one of those systems because there's so many components and so much wire that has to be run through there. So that's the biggest cost difference for me is, in the labor costs for the installation side of
Great. Thank you. My second question was, and you're actually that was a great lead in about the labor and all the wiring. But how are these systems programmed? We have not, or I have personally not worked on the battery system yet. So I'm a little new to the technology, but I don't know if they're pretty intuitive, like inverters are these days, that as long as you kind of know the jargon, it's easy to plow through and get them up and running, or does it take any kind of special training? What have y'all found out with installing batteries for so long?
it. As far as what I have seen, the ones that I've installed, they do have a course. You have to go through the course to get certified to work with them and to program them. And some of these systems, they actually give you a code that you have to put in to be able to commission the battery, and the person who's going through the training has to commission the battery. And others is just simply program what type inverter is in it, or program the inverter for what type battery you have, flip a switch, and you're pretty much up and running. How about you, Bruce?
Yeah, our experience with Enphase was there was an 8-hour training certification course that you had to go through, and then out on the site itself, you spend a lot of time with the installer out going through and checking this and checking that. So yes, there is a lot more effort that goes into it. It's not quite as straightforward or plug and play. So yeah, it does get a lot more complicated.
Great, thank you.
So if we dig it, because we're not getting past 3 feet on the hole, but we dig it 3 by 3 by 3, and then put rebar. We have to cut some of the post off, 2 foot of post.
So cut 2 foot of post and we'll bolt it back onto it.
Yeah, I can do that.
Yeah.
But if we can get it 5 feet,
You can't tell our panelists on construction sites for
we
today.
can get 5 feet.
Maybe in the meantime, I have a question. You mentioned earlier about selecting the right appliances for your house when.
All right. Y'all do the best you can. Let me know what you got to have. Okay?
What exactly do you mean by that? Can you give more detail?
And I think what you were asking about was about the appliances and what I said about sizing your system and your appliances.
Correct.
Yeah, what that is I'll start with like the air conditioning for the first example. Whenever you have a battery system and battery-based inverter, and you cannot put a normal air conditioner on that. And the reason being is the startup surge. If you ever stand next to an air conditioning compressor, whenever it comes on, it sounds like, it's just, I call it just hitting hard. The compressor instantly comes on. Well, when that compressor comes on, it's a big surge to get that motor turning and getting that refrigerant pumping. And the inverters and the batteries cannot handle that startup surge of the, on the system. And what it'll do is it'll trip it out, and you pretty much, don't have any power. So what you have to do is you have to put a air conditioning, what they call a variable speed compressor on the air conditioning system. So instead of having that hard hitting startup surge, it gradually ramps up to what volume of cooling that you need at that time. And they're also a lot more efficient because you don't want to put a 30 amp or 40 amp air conditioning compressor on a battery system, or your batteries are not going to last but just a few minutes to a couple hours, depending on the size of the battery. Another thing that you have to look at is your lighting, your refrigeration, and your kitchen appliances. The lighting, you want to have LED lighting if at all possible in there, unless it's one that you got to have an incandescent. Make sure it's a small wattage incandescent, because every light bulb on the system adds to the amount of wattage that's being used and the amount of amperage and the amount of energy that's drawn out of those batteries. For your kitchen appliances, you want to have a high efficiency refrigerator that's not going to have the actual startup surge. It's a smaller surge, but still, depending on what you have running in your house, it could be enough for one to trip out the inverter, because the inverter is going to trip out to protect itself and protect the batteries. You want to have like a gas stove or gas oven and gas cooktop, because if that is on your solar, if you have a whole house system, if that's on your solar, that is going to run your batteries down real quick, because if you're cooking a cake for an hour or something like that with the power out, you're not going to have enough battery power to supply that thing for an hour. If you did, then you got a lot of money there. So all that weighs into sizing the system and making sure the system is sized good enough to handle the loads that you're putting on it. And those examples are examples for a whole house system. If you're only going to do for backup, then what I tell people is back up whatever lighting you need for the rooms that you're in, a TV in one of those rooms, and TV and internet in one of those rooms, so you know what's going on out there in the world, and your refrigerator. And if you have a garage, you want to have your garage door opener on that system. So if you come home, the lights are out, you can get into the safety of your garage. You open your garage door, get into the safety of your garage, and close your door before you get out of the car, especially these days of how crazy people are these days. So those are the main systems that you want. If you have like a Rinnai or tankless water heater, you want to have the power for that, the control power for that on your battery system, so you can at least have some hot water in there too. There's a whole list of things, but every one of those items, besides the Rinnai, every one of those items is a load, and you have to size that system for that amount of loads that you have. If you miss one of those loads, or if the customer comes back when you're installing the system, they're like, you know what, I was thinking about it. I think I want to put this load on there too. I always size it a little bit above, because you always know that there is going to be that customer is going to think of something along the lines that they're going to want to add, or that they're going to go in there and add after you leave the job, and they'll be Mr. Handyman and go in there and put it in there themselves. So you want to upsize it a little bit, but you don't want to go crazy with how much you upsize it.
A good point, Jamie. So to kind of recap, if you got a 1,500 watt well pump, you've got a 1,000 watt coffee maker or toaster oven, you add up your lights, those total demand is going to determine the size of inverter that you need. Now, how long do you want your power to stay on and to use those appliances is going to determine how many batteries that you need. So the total demand that you're going to place on the machine dictates the size of it, but then how long you're going to be able to run it dictates the kilowatt hours that you would have in your batteries to meet the customer expectations.
And that's why we have two of us on here, because he is a lot better at explaining all this stuff than I am, because I'm out here in the field installing all this stuff, and I could pretty much almost do it blindfolded, but then explaining all of it, that's something I have a lot of trouble doing. So I'm glad Bruce is on here with me, and we're doing it as a team to have both of us try to explain all this.
Yeah, it is a complex subject, and before we get too far and run out of time or anything, I'd like to talk about safety. Putting batteries in a house is it seems simple. Oh yeah, but as an afterthought, what's going to happen if an electrician comes out there and work on that house and don't know batteries are in there? You got power on. One of the worst things that I have run into recently was I had another installer who had went and put in a battery system with the inverters, and he was going to feed the whole house back. Well, he did not put a gateway or a switch that would open that home from the utility. So the guy called me, said, my power went out. My battery only lasted about 30 minutes. When we went out and looked at it, he was powering everything in his home for 30 minutes, but he was also powering his neighbors' homes until his battery ran out, because that power will pass straight back through your meter if you don't have a gateway or a switch, and it will go back through the transformer and can power your neighbor's home. But the risk that really presents is, what if one of the electrical linemen was out there trying to repair a broken line, and he reaches up and catches what should be a dead line, but that battery is sending that power back. So it's very dangerous if you don't know what you're doing. When you start feeding this power back, if you send it back through the main power line, you can have some big issues as far as creating an electrocution situation. Also, if you're sending it back without that gateway in there, electrician comes out, says, well, I'm going to work on your house, I'm going to pull the meter so it'll be dead and safe. If you're making electricity and sending it back, that's not going to happen. So, it needs to be installed right, it needs to have the right signage. Safety is a very important thing. We never want to hit one of the utility electricians or an electrician that just come to wire up something else into the home. And so it must be installed right with the proper gateways, switches, transfer switches, and signage, so that people don't get into an unsafe situation.
Yeah, and to add to that, I got a call one time from a guy that he went to, I think it was Northern Tool or one of those places, and they sitting out there right at the door, they had this solar inverter, and it showed where you could plug in appliances to it and everything. And well, the guy asked me, he's like, I tried to hook this thing up, but I can't get it to work right. Can you come out here and take a look at it? He didn't tell me what type of solar inverter it was. He just said it was a solar inverter. And went out there, and what he had done was he had taken the solar panels and just put out in his yard and ran the wire across his yard and into this inverter, like you would see in a RV or a pickup or something like that. Like, I think it was like a 1,500 watt inverter. And he had taken and cut the end of an extension cord and put 2 mil ends of the extension cord. He plugged one into the inverter and one into just the closest outlet that he could find to plug it into.
Oh
He was
God.
trying to run his whole house off of that. He didn't turn off his main breaker or anything like that whenever he did it. So pretty much what he did was he burned up the inverter by plugging it in. But what he could have done is, if the power was out, just what Bruce said, he could take that 1500 watts at 120 volts, shot it straight into the line, into the transformer, and lit up his neighbor's house until the inverter finally burned out. So it's not for anybody to really mess with, even though they sell this stuff for homeowners to install and for homeowners to think they could install. But what they don't put in those fine prints is just the dangers that there is in doing this. These days, like what Bruce said earlier about the voltages, you're working with up to almost 600 volts direct current, 600 volts packed in these battery cells, just ready to reach out and touch somebody. And let me tell you from experience, when it touches you, it doesn't feel good. It doesn't feel good at all. And it could kill you before you even realize that you're dead. That's how bad it is. I think we did have a question earlier.
We do. Gene Wilson is wondering which variable speed air conditioner do y'all feel is best? Do y'all have a preference?
The air conditioners are like the cars. You got Ford, GMC, Ram. You got fans of all of those. Air conditioning systems are pretty much the same way. But what I personally have at my house is an American Standard, which is a Train brand. That thing's been pretty much bulletproof the whole time. There's a lot of electronics to them these days, especially with the variable speed compressors. Some of the compressors are variable speed, and that, it's just like the fan motor on a circulating fan or something like that, or on your ceiling fan where you have 1, 2, and 3 speed. Those aren't the ones that are good for the solar. The ones are the ones with the variable frequency drive units that just rent, that's pretty much almost, limitless on the speeds. It's kind of like Varisistor or something, like on a dimmer, on the old style rotary dimmers. It's pretty much the same principle, but it starts out slow, and most of those don't even turn off. They just continuously run the refrigerant into loop, and they just ramp up slowly. And because they run the refrigerant into loop, there's no hard startup current going on there. It just has to say, okay, we're running at 3%, just circulating the refrigerant slowly. Okay, we need cooling now, so we only need 15% cooling, so it goes from 3% up to 15% power. And those are the best ones, the ones of the variable frequency drives and stuff like that.
We've had a lot of good experience using the mini splits. There's quite a few out there, Mitsubishi, Mr. Slim, Mr. Cool. There's a lot of different brands out there, but those are, like Jamie's talking about, they use inverter drive technology there, and they ramp it up slow so you don't get the hard pulse, but also they have a high SCER rating, anywhere from 20 to 28 SCER, compared to a lot of the conventional air conditioners that might be in the 10 or 12. So they're very efficient, and they will crank up using inverters, has been my experience. And those are, like I say, the mini splits that can be a lot of different configurations there. But just the old standard compressor out there with the contactor that clicks and it's wide open, those are very hard to run. We've been able to have success by putting some soft start kits on some of those in the past, but that's not the best solution. It's better to use the variable speed drives when possible. If you are going to try to run one, you've got to look at what your full load amps and your starting amps are on the machine, that's going to let you know if that will knock your inverter out or if it's going to make it work. You gotta be within your budget on the amps.
Hey, Bruce, you want to explain to them about the amp draw and how the amperage will kick out the inverter? I think you might be able to explain a little bit better than I can.
Well, really, depending on the inverter, for example, you may have a 8 kilowatt inverter that can surge up to 1600 watts. So the 8 kilowatt can surge up to 16 kilowatts, and there's a lot of capacity, but it's only for a few seconds. You've got to make sure, number one, that your battery can give up the amps at the same rate that your inverter can make it. So if you don't have enough batteries, or if you have too smaller batteries that do not have the output capacity, you can overrun it real quick. And if your voltage starts to go down, if your battery voltage starts to go down, the amperage starts to go up, and that's what it will trip your breakers out if you have those big surges on them, just on the excessive amp draw. And some will hold it longer than others before they trip. Some trip instantly, but some are designed to hold that surge for, maybe 20 seconds or 30 seconds or something like that. But definitely, if you don't get it sized right, you are going to have problems.
Great, thank you. We've got about 10 minutes left, so if anyone has any questions, please go ahead and type those into either the chat or the Q&A section. And before we kind of get final thoughts from Bruce and Jamie, and if anyone has any questions now, I do just want to remind everyone that our spring awards meeting is going to be virtual, and it's going to be May 18th at 1 p.m. I think we will 2 hours, it'll be 1 to 3. And thank you, Jamie and Bruce, for joining us today and being presenters, and thank you everyone who joined us via Zoom to experience this, I feel, very informative presentation. So rounding out the conversation, Jamie and Bruce, final thoughts on battery power, when to go solar, when to go battery powered, anything that just stands out in your mind that you would tell to either consumers, installers, or even utilities.
Go ahead, Jamie, and lead off.
Well, obviously I'm a real big fan of it, seeing as that's how I live, is off of it. But my final thoughts on it is, if you own a solar sales company, or if you are a salesman or installer, please get training on it before you go out and sell it. Because it's real easy to go out there and throw a price down in front of a customer and tell them to, this is great for you and this is how much it will cost. But if you do not size the system right, you don't have the training to size the system, and you just throw that number out there and they bite at that number. But whenever the installer goes out there and installs it, and it does not live up to the promises that you have given that customer, that's going to be a very unhappy customer. And I know myself, I do not like unhappy customers. I like happy customers, because happy customers mean referrals that you don't have to pay for. And word of mouth advertisement is the best thing. And one bad apple there will spoil the whole bunch for everybody, not just for my company, not just for Bruce's company, but for everybody's company, because you want people loving solar out here. You don't want them to hate solar. You want them to love the solar installers, the solar companies, because if they hate one solar company, they're going to hate every solar company. So on the battery side of it, please get training on sizing and tell the customers the right sizes, and let them know that, hey, if you add something to it, what we size your system at might not work in the future if you add something. We need to get it set up so you have enough battery capacity to do what what you want to do now and pretty much what you want to do in the near future also. How about you, Bruce?
I think you're dead on with what you're saying there, Jamie. Whether you're a consumer or an installer or the salesman, do your homework, understand what you're getting. I have found my success in solar has been the better I can set realistic expectations for the customer, the better I can meet it and the happier the customer is. If you got a customer that comes in and says, I want a battery system and I want solar here, I don't want to know nothing about it, let me just write you a check, I would not touch that. That guy's going to be upset because if he don't know nothing about it, it's not going to meet his expectations probably. So in the process, whether you're the homeowner or the installer, in the sizing planning stage, let's talk about the hard things. When the power goes out, what do you want to run? And make sure, even if they don't ask the questions, that you explain to them what it won't do. I mean, that's one of the things. It seems redundant, but somebody calls, wants to put solar in. We do a grid tied system. If we don't tell them that it's not going to work when the power's out, we may have them call when the power goes out and says, hey, this system didn't work. If you don't put batteries in, it's not going to provide power. So make sure that you do your due diligence, that you understand what the expectations are and design the system around that, but make sure the customer's fully engaged and you know what he wants it to do when it's over with, when you walk away from the installation. I've had customers who want to just keep adding. And, as the salesman sometimes, oh yeah, we can do that. Oh yeah, we can do that. But make sure that the numbers work. That's what's going to be the make or break moment. But there's definitely a great options. There's great solutions that you can do with solar, but it only works if you size it and if you set the right expectations. Otherwise, somebody's going to have a $30,000 or $40,000 piece of equipment that is not doing what they expected, and they're probably not going to be happy, and they're not going to talk good about you. Main things, do your homework.
Absolutely. And one thing that I do want to kind of reiterate that Jamie said, and it reminded me of Chris Vernon, whenever she would always, because you mentioned LED lights and high refrigeration, is before you even go solar, before you even select battery, make sure your house is efficient. So you know what you're running. Bring it to the 21st century, get everything efficient, and then that way you know your true load for solar. And you can also bring your cost down with installations by having a lower draw. But Jamie, you remind me of expression. We just haven't at some of our past couple of meetings. With that, I think I don't think we have any questions in the chat box or in the Q&A. So again, thank you everybody for coming. And if Bruce and Jamie have nothing else to add, I think we'll end today's meeting.
I have nothing to add here. Thank everybody for being here today.
Absolutely.
Thank you, Roxanne, for all the work you're doing, and Solar Council for getting information out and sharing it with people so we can at least deal with the good stuff out there and make sure we keep the bad stuff out. Thank you so much for all you're doing.
Keep them happy. Thank you, guys.
All right.